Rhianna Robinson is a research scientist within the Forest Product Innovation Team at the Queensland Department. Rhianna is leading the Queensland Government DBI project. I was at the DBI conference in 2026, so next year. So I take a huge role in that conference. And some of Rhianna's expertise include research characterization, engineering wood product development, timber preservative and fire retardant treatment, optimization, understanding on embodied carbon in timber. Thanks me to Rhianna to present what the outcome of last year's project. Thank you, Rhianna.
All right, thank you. Thanks for having me here today. As Benoit said, I'm going to discuss the outcomes of the last DBI workshop. So in September last year, a group of us, some of who came last year, which is great to see same faces again. But we actually followed through anything that was voted for in the previous round. We collated, shortlisted, went through and developed proposals. And these were shared with the University of Melbourne, who's our overall funding provider. And from there, we've delivered 2 projects. We're just in the very final stages of wrapping these up. If you'd like to see these in the future, they'll be available pretty soon. So the 2 projects that came out of the workshop last year, which were voted for, was the challenges of reutilising engineered wood products and treated wood waste, and investigating the methods of embodied carbon calculations for the timber industry. So this has been prepared by us at the Department of Primary Industries, myself and a colleague, Chris Fitzgerald. All right, just a little bit more background about the whole project. So it's obviously led by the University of Melbourne underneath the fund. So the Department of Primary Industries is a collaborator with the University of Melbourne, and we are obligated to deliver 8 research projects across the duration of the Decarbonising the Building Industry program. So the 2 projects I'll be talking about today, these first 2. In the next financial year, we also have another 2 projects, which is what we'll be talking about today. And then in the following financial year, we actually have 4 projects to deliver. So if something of interest doesn't appear today, it may happen in the future too. So as discussed from that meeting with everyone here, there was 15 votes for working on this and another one in a sort of related topic. And they'll probably find that today again from the workshop roundtable sessions, is that the same themes might appear across different tables, and that is completely fine. It just shows us that's a good pulse point and of interest for everyone to work on. So yeah, just moving forward today, anyone feels like you want to table anything or propose anything, we actually will review it and actually have a look at it. So as I said, we're just wrapping this up. We've developed a pretty comprehensive review of the things. There's a number of ways to challenge this. It's no small feat. And our next presenter, Penny, will do a great job talking about timber circularity and recycling of wood waste. But we did our best, primarily focusing on the waste generated from engineered wood product manufacture and treated wood waste. And there's a lot of other alternative avenues to use these waste resources, and we primarily wanted to focus on what are the challenges of reincorporating this waste and turning it back into engineered wood products so we can keep it in the stream specifically for forest products. We came up with a way of approaching this, and through talking through a few different industry partners, included technical barriers, the regulatory barriers, economic drivers, the perception around industry and the market component, and obviously our environmental and life cycle analysis. We developed a pretty good advisory committee who helped guide us along the way. And the feedback we received was to avoid the regulatory component because it's going to be pretty well covered. And our industry perception and market assessment, we decided to, instead of broadcasting a wide survey, we decided to narrow it down and really get the feedback from some of our industry partners as to what they really thought and get a bit more quality insider information rather than just a yes or no survey type arrangement. So in our technical barriers, we explored all the different types of engineered wood products and whether they could offer an opportunity for wood waste to be developed into them, and also their waste streams from their productions. We looked at all the different types of preservative treatments we use in Australia, their proportions, their performance, why we treat them, the adhesives that we use, and a range of things around characterization, resource collecting and sorting, all of that kind of thing. For our regulatory component, we decided to move towards health and safety and the key health and safety issues around developing products made from treated wood waste or contained adhesives, and any sort of policy incentives around that to get industry to move in that direction. Again, the economic drivers, what's holding us back, our industry perception and barriers. So One of the questions that we primarily ask to get a better understanding of is what's your limiting factor? What is the key considerations for you guys to incorporate recycled material into your products? Why is your traditional market primarily on virgin materials? Just really wanted to understand the thought processes behind there, or any hesitations, whether they were real or perceived. And then in the last section, we primarily focused on the environmental benefits. I feel like I'm preaching to the converted, but we all know that incorporating recycled material has many wins. It reduces the reliance on virgin material. It keeps our embodied carbon extended into new lifespans. And in a nation that's struggling to meet fibre demand, it's a huge opportunity for us to be more focused on circularity. So this is what we primarily found from discussing with our industry partners. This was the feedback that we received. We also found some very interesting information, and because of the information we received, we decided to aggregate the results to not, provide some anonymity. So one of the main considerations for industry was the capital investment into equipment to process recycled material, basically to get any recycled material, as Harrison said, to turn it into particle board or MDF or another form of reconstituted composite panel. There's actually a significant amount of processing, and it requires specialised equipment. This equipment is not easy to come by, and because of the nature of the things that you process are prone to degradation fairly quickly, because you're processing things that are not uniform, contain adhesives of varying strengths. You have a range of materials that could be processed as both hardwood, softwoods, and you're also having to deal with, for end-of-life materials, things that may also contain paint or other coatings or melamine or nails and screws and other contaminants that may have arrived on the way. So the capital investment for appropriate technology to handle and sort equipment was a massive consideration. And also the cost of landfill. And this is a really interesting one. We know in Australia that we already commercially practice, for example, Borg already commercially practice using recycled material for manufacturing particle board and MDF with significant proportions of recycled material. However, it was very interesting to find out that their business model relies on the cost of landfill being so high. They've decided to, instead of invest in paying for landfill, we'd rather invest in ourselves. We'd rather invest in the equipment to do this and invest in ourselves for the future. However, they still rely on a proportion of virgin material, where they have suggested that they could potentially go to 100% recycled material. We're able to ask a few more questions around the technical performance. We found that very interesting. The cost of landfill, even for other industry partners that we talk to who do incorporate wood waste into their production systems, still have a cost towards landfill, even people who are incorporating a significant proportion of recycled material. It is very significant, that expense. There is actually a lot of regulatory uncertainty. Our industry partners are actually not quite sure about the process to include that they would have to follow, including the end of waste codes. They seem, again, this is my personal opinion, I'll talk about it a bit later, but they're quite complicated to move in that direction. There's a fear of change and the introduction of red tape. Some of our industry partners currently do have circular processes in their supply chains that do incorporate wood waste. And because of the fear of change and the fear of introduction of red tape, these aren't commercially known or advertised. And some industry partners have indicated that they'd prefer it to stay that way. And they're doing everything right. They're making products that meet performance standards. These are entering the market, but for fears of they're not sure if they're going to meet the regulation or not, this is not widely advertised. Labour is a major consideration for them for incorporating wood waste. We know that it requires sorting, collection, categorisation, etc. All of this requires labour, human labour, and it is still one of the greatest expenses. And there's also a trust component of making sure that the people who are involved in that are collecting, collating and sorting things into the right categories for reutilisation. There's also a supply inconsistency and uniformity component to this wood waste issue, but I think Penny's going to do a good job next up talking about how to look at that on a broad scale. There's some of the industry communicated that they have a fear of entering into making things out of recycled products that do contain preservatives or adhesives around the performance issues, not because they are real, but because they fear that their customers will have that issue. And they also, that's connected to this concern of liability. They're comfortable with what they produce now. And if they were to include things that, example, just treated wood waste generally, they're not sure the circumstances that they would be used in beyond their current customers. So that's what we found from our industry partners. And I'll just very quickly summarize this. We were surprised to find that there's only 2 end of waste codes for timber. So there's the solid timber one and the ACQ treated shavings one. We don't know how much timber goes to landfill in Australia. Our national waste reports don't differentiate timber. They're hidden under construction and demolition and under organics. There's no further delineation. State by state, there's probably a little bit more information. However, it's in their reports as well that the total number is unknown. As I said, there's some circularity exists. There's unrealised embodied carbon wins for incorporating wood waste. All of the technical challenges that we've identified so far can actually be overcome. The cost of landfill is really significant and on the minds of our industry. And I think an outcome for me, and just to be aware of, they're just unsure of what to actually do to move in this direction. A few recommendations, pretty wordy, you don't have to read it. Particle board and MDF with the PMDI adhesive is a no-brainer. PMDI because it doesn't contain formaldehyde. So when you're reprocessing things that already have adhesives, PMDI seems to be more appropriate and compatible with a variety of different treatment types and also a variety of other adhesives when you're combining things all together. However, there are people commercially practicing it without that adhesive. There's an opportunity to disguise any recycled products within other things, melamine coatings or other engineered wood-based products. We need more simplistic waste codes to help our industry rather than hinder them. And it would be great to develop preservative-specific end-of-waste codes. Consumer-facing labels may help. Better understanding nationally or maybe consistent guidelines across state to state of how to dispose of timber. So it's of preservative-treated timber, In circumstances where you can avoid it, treating with ACQ or MCA, micronized copper azole, instead of CCA is recommended, just because there's far more end-of-life opportunities for ACQ and copper azoles rather than CCA. CCA is a bit tricky. And in terms of a practical approach, we know that in Australia, the majority of the timber is coming in construction and demolition waste. There's opportunities on job sites to sort this prior to landfills. So ultimately, sorting at recovery centres would be great for a bit more, but obviously land is a difficult component there. But the second part of that is we could do it earlier on. We have just a timber-specific skip bin, start collecting that resource so it doesn't end up in landfill. So that's the first project. A little photo up there of my colleague Chris Fitzgerald on the right, former colleague Bill Leggett, who's now at Griffith, and Brand Enkelbrecht from Borg, myself. This is an output of their screws and nails that comes from their particle board recycling. So when we're talking about the infrastructure to handle this kind of stuff, that's what we're talking about. Machinery that can handle, sort, and correctly dispose of in an automated way. So you can imagine what the complexity of that. Over on the left-hand side is an example skip bin from a frame and truss manufacturing group on the Sunshine Coast. This is making its way into some products at Mega Beam, where they reconstitute and make longer pieces of timber through finger jointing, and then these are pressed into big glulam panels. They're doing a great job. And just as an example, we're talking about this construction and demolition waste. This is just driving around the Sunshine Coast. There's lots of new developments going on. That's what an average skip bin looks like, just filled with perfectly fine timber resource. So that's the first project. So thanks everyone who contributed to that in our advisory committee and industry partners. Now for the second project, in my personal opinion, was fairly complex. It was voted for at the last workshop with a fair few votes, is to look and understand embodied carbon for the timber industry and also investigate the new international standard for wood and wood-based products. At the time when we developed, this draft was under review. It had not yet been published. This draft This standard now has only the ISO 13391 series has only just been published in the last 5 weeks. And the associated technical report that underpins that standard has only been published in the last 2 or 3 weeks. So we've done our best. And I will say this whole standard of forest carbon stock accounting and modelling is an entire discipline on its own. So we've done our best. So we're just finishing up that now. So our methodology was to basically have an overview of the carbon accounting methodologies in the timber industry, better understand the embodied carbon in the supply chain, have a look at what the commonly employed approaches are. And at the time of writing, this is a draft, but we reviewed the wood and wood-based products part 1, 2, and 3. Primarily, I'm going to talk about the forest carbon balance and the displacement of greenhouse gas emissions and just my recommendations for those. And I apologise to anyone who's very familiar with embodied carbon. I'm sure there are a few of you in the room, but one of my findings was that the literacy around accounting and carbon and embodied carbon, everything to do with that was fairly low. For the sake of it, we'll all upskill together today. And the reason we care as well is there's new sustainability reporting, which incorporates embodied carbon. This is now mandatory for all of our big industries. I can't remember the cutoff, but if you have over 100 employees or generate $50 million or are part of a reporting scheme, you are required to mandatory report your embodied carbon emissions. It's a really big deal, has a really big impact on our industry in Australia. Because while this is targeted at big organisations first off, big organisations use little organisations. And these guys are actually going to have to come up with the information to support embodied carbon calculations. And obviously there's environmental benefits, we all understand that. But this is a really significant opportunity at this point in time for timber to showcase its environmental credentials. It's a really big opportunity. So a life cycle assessment is a standardised approach based on ISO 14040. It is based on lots of interdependent standards, but it's basically a systematic approach to evaluating the environmental impacts of a product or a building across its service life. A life cycle industry is the information that's used to plug into a life cycle assessment. This is also standardised and based on lots of different things that basically interact globally. So Environmental Product Declaration, last year we had a great presentation from, can't remember his name, but the Environmental Product Declaration dude, he was great. He's from a summary from his presentation last year, basically this area is rapidly growing. It is trending. Every year, thousands more businesses are moving towards generating EPDs. And within an EPD, these are also standardised. And within an EPD, there are product category rules. Now, these product category rules are the rules, requirements, and guidelines for developing an EPD, and that is also standardised. What is not necessarily standardised, in my opinion, is the system boundaries. So whilst we have, I'll use a nice diagram, whilst we have all of these categories, for example, raw material supply, transport, manufacture, the boundaries within that are not necessarily optional, but they can be modified to make things look a particular way, in my opinion. This end of life stage is an important consideration as we continue this conversation, because the new ISO standard is proposing to incorporate and, I guess, model or predict what will happen at the end of the lifespan of these products, which is interesting. So just for an example, for a timber-based product, CLT, for example, this is from Arup. Everything involved with 81, it's raw material extraction for both any adhesives or any other thing that's incorporated with timber. Transport to where it's going to be manufactured. As predominant order, our life cycle assessments and EPD set is that A1 to A3. This A4 to A5 has a lot of variability and can really influence the overall LCA or EPD for a product. And just a very general comment, again, my opinion only, this can be used to make products look a particular way for an overall value based on what you decide to include or disinclude. For timber, we believe it's in our best interest to include this phase because we know that the longevity of the timber and potentially for sourcing close to home, these don't have to be that big. And for other industries, this can be really big. So just a note on this. So predominantly for our industries, we focus on primary data for these life cycle assessments and EPDs. We also rely on national data sets to input into these. These are predetermined numbers sitting behind in beautiful spreadsheets that you can actually access. And we also have, where it's been led, Forest FWPA aggregates data sets and does ones for specific product types. So the Australian Life Cycle Assessment Society and LCI have, beautiful website. You can go on, have a click. You can actually go in, find the timber ones and have a look at these numbers that already exist in spreadsheets for timber. Those numbers in those spreadsheets are based and connected to global data sets. So there's always opportunities in my opinion, to make these more Australia-centric and Australia-specific for Australian products. For the forest carbon dynamic thing, again, this whole sector on its own, we do have the full accounting model for Australia, FullCAM, and also the National Carbon Accounting System. And I believe there's someone online today who should know a lot more about that than I do. This is supported by the CSIRO data for biogenic carbon storage. So this is my general finding of the whole ISO standard, is that ISO wants to view our carbon stored within timber products as a total pool nationally for Australia. It models it as a big group, a big stock. And so for timber to demonstrate a change in the total carbon pool, we either need to plant more trees or grow more trees and turn them into products to enter the pool. But in my opinion, I think there's an opportunity if we can look at extending the design life and the durability of our timber products currently in existence, and also a greater proportion of recycled material entering our carbon pool, we have an opportunity to extend that as well. This forest carbon model through ISO is dynamic, so it changes and accounts for changes in time, whereas, for example, the British standard, the PAS one, is like static. This is what's happening right now. So what underpins this ISO framework is the technical report about the carbon stored in harvested wood products. It has a recommended tiered coefficients. So basically, depending on what entity you are, you can pick which one. Sure. And the main thing of interest that defined the half-life for sawnwood at 35 years, wood-based panels at 25 years, and 2 years for paper and cardboard. To me, this is interesting. The half-life is defined as this is the total pool of what we've got. And for that time period, 35 years, we expect that half of that product's going to be gone. I think that's interesting. And my other main interest point was this was based on European data. I don't think there was a single Australian reference paper cited in the development of this ISO standard. And there's an opportunity there to develop more Australian-specific half-lives. So thank you very much.